Hi, I'm Tanim, and in today's video, I'm gonna show you how to build a custom object detection model in just 2 minutes with minimal code and minimal computation power. So, let me clarify a thing. To train an object detection model, you need to have some things. The first thing is data. The more data you provide, the better performance you get. This is actually the logic. And the second thing is the algorithm you want to train in, like YOLO, TensorFlow, or Detector, Detectron, and etc. whatever. And the third thing is the machine you are training in, like your GPU, CPU, or whatever you have. So these are the criteria of building an object detection model. And the accuracy of the model depends on how much data you are training in or the algorithm. Here comes a thing. Like if you don't have a decent CPU or a GPU, you can't train a lot of data. And there's another thing also, like labeling a huge amount of data consumes a lot of time. So we can solve this problem using a tool called Teachable machines. So let's get into it. So this website is created by Google's Creative Lab, as you can see. And what they're saying is Teachable Machines is a web tool that can make it fast and easy to create machine learning models for your projects. Yeah, that's true. Like to train a model, you don't have to code, but to implement it and use it in your project, you'll have to code. And train a computer to recognize your image, sounds, poses, and etc. whatever. So so this is actually the website what we're gonna work called Teachable Machines with google.com. Yeah, that's it. So we're gonna click get started, and you'll see a bunch of options here. You can do whatever, but we'll do image project. And here's the thing, you can use a lightweight model too for your microcontrollers like Raspberry Pi or anything like microcontrollers. And here's the standard image model. We're gonna do this, and here we go. There is the interface, and it's really easy to train. What you have to do is like rename your class. Like if I give this a name, I'll say nothing. And for my class 2 is like and water bottle. You can add classes using this icon. Just click it and you can see there's another thing. So I don't want to do another, so I'm just gonna delete the class. Yeah, that's it. So you can upload the image or just capture this right here. So I'm gonna capture it because I don't have an uploaded image. If you have images stored already, just gonna click upload, and then see this options. If you click this, there is access to your PC and stuff. So okay, we're not gonna do it. We're gonna capture right now. So for the nothing images, I'll just capture my background. So this is actually my background, and I'm just gonna hold it to record, and it will capture images. As you can see, it's capturing. 98 is enough, and then we're gonna close it. And for the water bottle, I have a water bottle right here. So let's see. Yeah, that's it. That's a water bottle. So I'm just gonna hold to record. You can change the directions if you want for better performance. Yeah, about 100 images. Yeah, that's enough. The next part is the training part. So you can see an option here, the trainer model. So we're gonna click it, and it will take some time depending on how much the data is. Like we just have 100 images, so it won't take long. But in your case, it depends on the CPU's performance. So it might take long. As you can see, it started training, so we're just gonna skip that part. And yeah, bingo, our training process is done. So here's a cool thing about this website. So you can check your performance, like your model's performance without any code. So here is nothing, and it's showing nothing. Accuracy is 100%. And if we bring the water bottle in, you can see it's 100%. So the accuracy is amazing, but it has some backlashes too. So I'll tell it later. So for now, we are cool with that. So we have to export our model from here. And remember to download it in Keras.h5. TensorFlow, in TensorFlow. Then select Keras. So using Keras save model is really easier than TensorFlow save model. So click download and it will start downloading. Save your model. And after you download it, when you go to the downloads, and here it is, the converted Keras. We're just gonna extract that. Extract here, and it will give us two files. One is Keras model.h5. This is the trained model, and those are the labels. So yeah, that's it. Congratulations, you have trained a machine learning model. So our next step is creating or just testing it in our code. So this is our code. It's really simple, I'd say. So first of all, we have to import our packages, cv2, Keras, and Keras in preprocessor. And the second step is to define your model. To define your model, you just have to simply copy the path of your model. In my case, the path is this. You have to remember a thing. If you go to the labels.txt, we'll see that nothing is my first class and water bottle is my second. So you just have to follow the sequence. So I put nothing first and then it's water bottle. And this part is like the image processing, and this is the class label. So while a class is detected, I'm storing the data in class label variable. And this is really useful. Like if you wanna use your predictions, you can just simply write a code like this, like if class labels, let's label equals I'd say nothing. Then you can write your logic here, like if I say print Yahoo or something. Okay, so if nothing is detected, it will print Yahoo. So you can write your own logic here. I guess you get the idea. And here we're just outputting the class label onto display. So if you run this code, remember you just have to edit this thing and the class labels. You don't have to do anything with the other code. So if you run it, okay, it's on. So just have to switch to our webcam. Here it is. As you can see, it's printing nothing. And if we bring the water bottle in, bingo, it's detecting water bottle. If we move it, it's nothing. Water bottle, nothing. Yeah, water bottle. So this is actually it for a detection, but I just have to clarify a thing. Like, accuracy of the model was high class with just around 100 data, but in object detection you need a lot of data. So how did our model perform that well with just like around 100 data? Like, let me share a funny thing. Like if we change our background, the accuracy of our model will be like really bad. The reason for this is, like, while we are putting our images on teachable machines, it's not labeling the object. Rather, it's labeling the whole image. That's why a model thinks that the background is also the object. If we change the background, it can't provide a decent accuracy. So to get benefit from this model, you can't change the background. Otherwise, it won't work properly. So I hope this tutorial was helpful to you. Bye bye.